something we didn't know about. The length of a day oscillates every 6 years, and now scientists finally know why. How we think about our planet's center may need to be seriously updated. New evidence suggests instead of consistently rotating faster than Earth's spin, the solid inner core oscillates, spinning first in one direction with respect to the surface far above, then the other, changing direction every 6 years. I wonder what that means for the Earth's crust. Now, it's not only has implications for our understanding of the inner workings of our home world, it can also neatly explain the mystery that's perplexed scientists for some time, an oscillating variation in the length of Earth's day with a period of 5.8 years. From our findings, they said, we can see the Earth's surface shifts compared to its inner core, as people have asserted for 20 years. This is what geophysicist John E. Vidal of University of South California, Los Angeles, UCLA says. However, he says, our latest observations show that the inner core spun slightly slower from 1969 to 1971 and then moved the other direction from 1971 to 1974. We also note that the length of a day grew and shrank as would be predicted. The coincidence of those two observations make oscillation the likely interpretation, he said. Although our understanding of Earth's core has developed a lot in recent decades, there's still a lot we do not know. We can't just go there and take a gander at it. Everything we know, we've gleaned from indirect observations, such as seismic waves propagating and bouncing through the entire planet. But this is still a very effective tool. Scientists have been able to ascertain that Earth's inner core is probably a hot, dense ball of solid iron measuring about 2,440 kilometers or 1,516 miles across, a little bigger than the size of Pluto. Evidence also suggests that it demonstrates superrotation, rotating faster than the Earth itself. Researchers first detailed this phenomenon in 1996 with estimated superrotation rate of 1 degree per year. Vidali and his colleagues Wei Wang, also of UCLA, later revised the rate down to 0.29 degrees per year using data from underground nuclear tests conducted at the Russian Novaya Zemlya testing site in the 1970s. In the new research, they went back in time, adding 2 tests conducted below Amchitka Island in 1971 and 1969, and that revealed something very odd. The data suggested that rather than super-rotating, Earth's inner core was sub-rotating, that is, spinning more slowly than Earth's rotation by about 0.1 degrees per year. This, the researcher said, was consistent with oscillation. When in the full swing of its spin, the inner core super-rotates, but then it slows down before speeding back up again. The idea of the inner core oscillates was a model as a model that was out there, but the community has been split on whether it was viable, Vidali said. He said, we went into this expecting to see the same rotation, direction, and rate in the earlier pair of atomic tests, but instead we saw the opposite. We were quite surprised to find that it was moving in the other direction. The 6-year periodicity of the oscillation neatly matches other oscillations for which we don't have a confirmed explanation. Earth's days undergo time variations of plus or minus 0.2 seconds every 6 years or so, too, and Earth's magnetic field also oscillates with a 6-year period. In amplitude and phase, they match a periodicity of the model Vidali and Wang derived for oscillations of Earth's inner core. This means it will require more data to unravel, which could be tricky. The facility that recorded the data from the nuclear tests, the U.S. Air Force's Large Aperture Seismic Array, closed back in 1978, and underground nuclear testing is nowhere near as prolific as it used to be, thank goodness. Now, but further advances in sensor technology could mean that the detailed data needed to probe Earth's inner core is not so far into the future. The results so far offer a tantalizing hint that Earth's insides are a bit more complex than we knew. The inner core is not fixed. It's moving under our feet, and it seems to be going back and forth a couple of kilometers every 6 years, Vidali said. One of the questions we try to answer is, does the inner core progressively move, or is it mostly locked compared to everything else in the long run? We're trying to understand how the inner core formed and how it moves over time. This is an important step in better understanding this process. This has been published in Science Advances, and it's on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.